Hello everyone. Welcome back. Today we're going to have a short video to discuss the requirement of a hybrid solar, wind, and energy storage. This presentation was driven by the large number of questions that I received in the past few weeks regarding the integration of the wind system with existing solar photovoltaic system, especially for the Middle East. Winter is coming, the sun hours is being shortened, so people, especially in Lebanon, send me a lot of emails, a lot of queries regarding how to design a hybrid wind solar system for residential properties. In this short video, I would like to have high-level requirements, especially how to choose your wind charger controller. So during today's presentation, we will introduce the main component of a solar system, the main component of a wind system, and what's the minimum requirement to integrate them together. Solar system component, we discussed all these items in a previous videos. How to design them, how to choose the equipment, but number one, it's your solar panels. The solar panels convert, the role of the photovoltaic system is to convert the solar radiations into direct current, DC current, or DC power. Then you will have the solar inverter. The solar inverter, my recommendation is should have maximum power point tracker, MPPT. What's an MPPT role? The MPPT role is to track the maximum power output of the system. As we spoke in a previous solar system design, the solar panels or solar cell can be considered as current source. The current magnitude changes with solar radiations. The voltage for the open circuit almost the same. So the MPPT role is to track the maximum power of your photovoltaic system. That's the main role of your MPPT. Then you will have your charger controller because you will need to charge your batteries. If you have a battery system, it's not a grid connected, you need a charger controller, and then you need a DC to AC inverter to invert the solar power to AC and to invert the charger controller, the batteries, into AC for the house usage. And AC to DC. In many hybrid systems, you should have an AC to DC to charge your battery when the grid is available. If you want to, you can choose the source of charging your battery. So this concludes the solar inverter, and of course you need to have your battery, and the battery will be used to store the surplus daytime energy for nighttime deployment. That's conclude our solar system for residential property, for a hybrid residential property. Now, we want to show you a diagram. How's the solar system? Now, these PV panels can be connected in series and parallel, depend on your inverter, depend on your MPPT requirements. So it will go to your MPPT to track the maximum power point, and then it will charge the battery, also goes to the inverter, and also from the battery goes up. Now, your MPPT usually integrated part of your charger controller. So this will be as a one. And the modern one, all this are integrated into one box, one system. The MPPT, charger controller, and the inverter are all of them into one system. This represents the PV solar system. The battery voltage during charging, I want you to pay attention to the following items. During the charge stage, the battery, for example, 48 volt battery, it's not 48. It's set at 45, 46. For a lithium ion, you could set it to 58 volt. This 56 and 57 volt play an important role when it comes to your wind system. You will see. So the floating, so after your battery is being fully charged for a 48 volt, some of them are set the floating voltage to be 54 volt. And if you look at the new lithium ion battery and the batteries, the operating voltage of 48 volt batteries is between 58 to 42 volt. I'm putting all this information because we want to utilize this information now to see how can we collaborate, how can we work together with the wind system to meet this requirement and for the wind system to be efficient. What's a wind system consist of? What's a wind system consist of? Number one, it will consist of a wind turbine. The wind turbine contains your permanent magnet generator for a small wind system, contain the blades, and of course you need your post. Guys, 90% or 95% of small wind turbine for your residential property are made of permanent magnet. Guys, pay attention on the 3 wires on top. This, because of the rotation, will give you a 3-phase AC circuit, alternating current at a different frequency, different rotation, depend on the rotation of your blade. Now, after you go to your blade, you have your charger controller. Also, in the wind, the charger controller should also use an MPPT because you also want it to track the maximum power point of your wind system. So my recommendation again is to go ahead and use an MPPT to track your maximum power point at the wind level. Okay, guys? So that's very important. Also, in a wind, you must have a dump load. You must have a dump load. What's a dump load? Dump load, it's a resistance. I keep doing it. It's a resistance. If you have the wind speed still exists, and you have your load, you don't have additional load, the battery is fully charged, where would you go with your power under heavy wind? This dump load will allow all the excessive power beyond the system control to be dissipated to avoid any damage to your system. It's a very critical to have the dump load for your system because you are not connected to the grid. You're not injecting everything to the grid. The grid called infinite bus because it can take all your excess power can go to your grid. Now, when you have a wind system, that's what we spoke. I told you about the 3 wires that goes out of the wind turbine. You have an AC. So first you will have a rectifier to convert AC to DC. After you have your AC is being rectified, and I would like to highlight one point, that the output voltage, for those who study electric machine, they know the speed, the output voltage, the internal voltage of your generator depend on your speed of the machine and the magnetic field. The magnetic field, it's a permanent magnet. It's been established by the permanent magnet. And the manufacturing of your permanent magnet wind generator is already done. So the speed determines the magnitude of your voltage, the relationship. So then after you go to rectifications, you do the rectifier, you will have a DC. And this DC, you go to DC converter to go to your batteries. So I need to make sure that the system is capable to charge my batteries. How would I charge my battery if my battery is connected to my solar system? If connected to a solar system. Inside your charger controller, inside your DC to DC, depend on your rectifier. What type? Do you have a thyristor? Do you have a full bridge diode? What type? What type of control gate do you have? You must have buck or boost type or buck boost depending on your system. We're going to explain what's a buck and boost type converter. For you to charge any battery, you should have the source voltage bigger than the battery so the current can flow this way. That's a principal concept of circuit analysis, electric circuit. So you need to make sure that your DC output voltage of your wind system, capable to send current to charge your battery, to send flow of electron to charge your batteries. Now, pay attention. When I have a combined system, hybrid solar and wind, I have my batteries are fed from the PV panels and the small wind turbine. I have my batteries being fed from both. We spoke before that my voltage during charge is 57.6, 57, 58 volt. So what will happen? What will happen is I need to make sure under low speed wind turbine, because the voltage increases, the internal generation voltage of your wind turbine increases with the wind speed. So to reach 57.6, maybe your wind speed, if you don't have the boost or the buck or the advanced electronic circuit, power electronic circuit, if you have a normal full wave rectifier, full bridge rectifier, normal one, so the AC circuit, the three-phase AC voltage increases with the wind speed. For you to reach 57.6 volt on your system, if you have a 48 volt system, your speed might be 30 or 35 kilometer per second. So about 10, 9, 8, 10 meter per second of your wind. So now, what's my solution? What's my solution? My solution is to use a communication. If possible, a communication. It's recommended to have a communication portal with a solar inverter and the battery terminal to adjust the DC voltage at its output. How can I adjust the DC voltage on its output? Is by using stuff known as buck boost converter. The buck and boost converter regulate the output DC voltage of my wind system to suit my battery requirements. to suit my battery requirements. So recommendation is always, first step, try to purchase one controller that contains the input from the wind and input from the solar. This if you are designing a new system. But if you have an existing solar system and you want to buy a wind turbine, I recommend you to have the wind controller MPPT have a boost and buck functions. Make sure the MPPT range voltage, you need to make sure the MPPT range voltage matches the output, the output wind voltage. You have to. For example, if you have a boost converter, you need to make sure the boost converter, for example, what's my output DC voltage on a 3 meter per second wind? Is it 20 volt, for example? I want the boost converter to work, start working from 3 meter per second, which means I need it to step up my voltage from 20 volt DC all the way down to 57.6, if it was 57.6, the batteries. The role of the boost function is when you have slow speed, the output is low of your turbine, the DC output outside after the rectifier, it's low, it will step up the DC voltage to meet my batteries. And the buck converter, if you have a heavy wind, the output voltage will be higher than your battery, the buck reduces it down. So, for example, for a 48 volt system, battery system, I recommend you to have your wind turbine controller has a boost that works from 20 volt all the way down to maybe 55, 60, and has a buck inside, buck converter that works from, for example, from a 60 or a 58 volt to 100 volt. This system, it will advance, it will make sure, even if you have a small wind, it still will contribute to your battery, charging your batteries. If you don't have this function, under small wind, you will not charge. So the wind turbine will be running, but there will be no output power out of it contributed to your system. So that's very important, guys. Remember this. Whenever you go and buy the system, you should look for these two functions. Recommendations. I strongly recommend the following. You should have mechanical protection for both the structure that you want to install on your solar. It's very important. If during heavy wind it will shake, it will cause a micro cracks. Micro cracks could cause hotspot, burn your panels. Could cause a snail. This micro crack, it will let the humidity goes inside, will damage your panels on the long run. So you have to be very careful. For your wind turbine, guys, when the wind picked up and you have a magnetic field now start working to generate electricity, you have an electric and mechanical torque. So you need to make sure your post is strong enough to hold, and you don't want your system to be damaged. Electric protections. I always recommend you guys to always install electric protection on the DC and AC side. It's a very important. Electric protections protect your equipment and offer you a safe working environment, safe living environment. Installation of a lighting. Guys, it's a very important, especially in winter, to have some sort of lightning protection by installation of a mast, or go install a surge arrestor, lightning surge arrestor along the way, and we've already done a video regarding these items. Adequate earthing system. It's very important for all this protection to operate, to have an adequate earthing system. Without an adequate earthing system, you will have no proper protection or adequate protection. Guys, shading, especially when you install the post of your wind system, make sure it's always behind your solar panels and avoid shade. Permanent shade could cause hotspot. Hotspot could damage your panels. Also, it will reduces your output power. So it's a very important, guys, very critical to follow this recommendation. To conclude, one of the most important elements when you want to incorporate wind system into a solar system, you should check your controller of the wind. Does it have a buck boost functions? And also you should check the buck boost functionality. Is it have the right voltage for the right speed in your city, in your town? I hope that was informative for you, and I hope you learned, and if you have any clarification, please send me a comment. Thank you all for listening, and I will catch you during our next video. Thank you.